So this video is going to be part one of a two-part series where I write a compiler in Haskell. This part I'm going to write a parser, and part two I'm going to be writing a code generator. So the reason I chose to write a compiler as the subject of these videos is that compilers are often thought of as being too hard to write on your own, something that's best left to the experts or black magic or something. But it turns out that writing a compiler for a relatively simple language is actually not that hard. It's just when the languages start to get really big and complicated that writing the compiler can get harder. I'm going to be writing this compiler in Haskell because it has a very good parser library called Parsec. The concepts in this video should be able to carry over to other languages though. For example, I know Rust has a pretty good parser library as well. And I'll be explaining anything unique to Haskell that would be unfamiliar to the non-Haskell user. So before we start, let's see how the compiler is going to work. So we have some sample code written in my language. This code starts out at 5, then it prints it, and then it decrements it, and then it repeats over and over again until the variable is 0. So what's going to get printed out is 5, 4, 3, 2, 1. Note that there's only 4 different types of declarations in this language. You declare a variable equals a constant number. You can loop while a variable is positive. You can print a variable, or you can add a variable by another variable. So before recording this video, I made a reference compiler so I could show you how the compilation process works. So if I run the reference compiler, you'll see that it made a C file rather than an executable file. The reason for this is that it's easier to generate a C file than it is to write out the executable file machine code line by line. And there's already C compilers out there that can turn the C code into assembly code. If we look at the C file, we'll notice, if we compare it to input.txt, we'll notice that these lines over here line up one-to-one with the lines in input.txt. A equals 5, b equals -1, while a is positive, print a, and a plus equals b. And then there's some lines beforehand and afterwards that make it so that the C compiler is able to read it properly. So in order to actually run the program, you need to call the C compiler on the output.c, and that makes an a.out. And running that, we see that the program behaves as we would expect. So now that we've gone over how the compiler is going to work, let's start to write it. The general way that our code is going to be structured is we're going to have a type code that we're going to define in a minute that represents, like in an abstract way that's easy to manipulate, the structure of the code that the person writes. And the compiler is going to have 2 different parts. So part 1 and part 2 that we're going to be doing next video. So part 1 is the parser. And what this does is it's going to read the file input.txt, and that's a string. So it's going to be converting that string into this code type that we're going to be defining in a minute. So the reason that we want to convert to the code type is because this is much easier to manipulate than the string that's the text of the file that has a lot of unnecessary information that we can ignore, and it's just generally harder to manipulate. So parser goes from string into code. And part 2 that we're going to be doing next video is going to be the code generator. And what that's going to do is it's going to take code. Oh, I should specify the string that the parser takes in is input.txt. And then the part 2, what we're going to be doing is we take this abstract code that we defined and we're going to be turning it into a different string. This time, it's the string that's going to go into output.c. So now that we kind of have the layout of our of our code, let's define what this abstract type actually is going to be. So what is code in our language? Well, code in our language is just a list of statements. Statements being print a equals 5, and so on. So code equals list of statement. So then that leads to the question, okay, what's a statement? So in order to define a statement, we're going to make an enum type. So enums in Haskell are done by putting different constructors that it could be. So it could be E or A or C or so on. Like a familiar example might be like if you're doing an enum for weekdays, you could do Monday or Tuesday or Wednesday. The difference in Haskell being that enum types can also have data associated with them. So for example, if the weekday is Wednesday, we can also attach like a time for what time on Wednesday. Or if it's Tuesday, you could attach like an integer for what day in the month is it, or something like that. So in our case, we have 4 types of statements. We have a print statement, we have an assignment statement, we have an add statement, and we have a while loop. So each of these have different types of data associated with them. The print statement has just a variable associated with it, which is the variable we're going to print. The assignment statement has a variable and an integer. So a equals 5, variable is 5, variable is a, integer is 5. Addition is going to have a variable and another variable. So like a plus equals b. First variable is a, second variable is b. And while loop has a variable and some enclosed code. So if we have like while a is positive, print 5 or print a, then the variable is a and the code is print a. So one more thing that needs to be defined is this variable that we kind of put here without saying what it is. But this is easy enough to define because it's just a string. So like A, B, ABC, so on. So type var equals string. One thing we want to do right now before we do anything else is we want to add this little deriving EQ show. And what this does is that it adds an equals operator and a function to turn these statements into strings, which will just be convenient for us later. So now that we have variables, statements, codes defined, let's play around with this a little bit in the REPL. So the way to get a REPL for Haskell is with GHCI. GHC is the Haskell compiler. The I either stands for interpreter or interactive, I'm not sure which, but GHCI is the Haskell REPL. So if we type in our file name, then our REPL will be able to access the stuff that we just defined. So in the REPL, we can do Haskell expressions and it'll evaluate them for us. We can also figure out the type of different things. So type of ABC is a list of characters or a string. So what we want to see is the type of print ABC. And as we would hope, it's of type statement. We can also have type of like assign ABC to 5. So ABC equals 5 is a statement. We can also have a while loop. Let's just look at that. So while ABC is positive, print B, and then add ABC by B, just for example. And this is also of type statement, which is what we want. So now that we have the abstract type for our code defined, let's start to write the parser, which is able to read the input file and convert it into our code type. So for writing our parser, we're going to be using the Parsec library, which is a Haskell library that is very nice for for writing parsers that you can combine easily. So we're going to be importing three different things. We're going to be importing text.parsec. We're going to be importing text.parsec.string. We're going to be also importing text.parser combinators.parsec.number. And this adds in a parser that is able to parse integers. So if I reload this, it reloads just fine. If you're typing this live along with the video and it errors, that might be because you didn't install the Parsec library. So if you want to install the Parsec library and you have the normal Haskell installation going, the way to do it would be cabal install parsec. I'm not going to type it in because it's gonna error on my computer, but this is how you would install it for you. And then you also need to do cabal install parsec numbers. Is it numbers? Yeah, it's parsec numbers. And that gives you this import here, text.parser combinators.parsec.number. So now that I'm assuming that you have Parsec installed, this should be able to load now. So let's see what Parsec is able to do. The most important function in Parsec is the parse function. You provide a parser. Let's say we want to parse an integer. You provide a file name. We're just going to put in a dummy file name here because we're not actually parsing a file. We're just parsing text that we provide. And then finally, you provide the text to be parsed. So 1, 2, 3. We're going to parse this text. And the result we get out is write and then a result. So write means that it worked, and then the result is what it was able to parse. Note that this is an integer and not a string. If it's not able to parse what we put in, so if we try to parse ABC as an integer, it gives left, and then it says our file name, and then it gives a useful descriptive message about why it wasn't able to parse a string correctly. So let's look at a few more parsers that we can do. Let's say instead of parsing an integer, we want to parse a character. The way to do this is pretty simple. Car. Note that it just parsed the first letter of this string, even though there's more letters available. Parsec is able to do this. It just ignores the rest of the string if it stops short. Another thing we might want to do is string, and we want to specify a string that is specifically looking to parse. So we have AB, and then it parses the string AB. Another useful tool in Parsec is this little operator, the pointing to the right. So this means that, let me give an example. We want the string AB followed by an integer, and then at the end it returns the integer. So if we have AB123, it just returns the 1, 2, 3. If we want to return the thing on the left instead of the thing on the right, we use this little left-facing operator, and now it returns AB instead of 1, 2, 3. I mentioned before that if Parsec, if there's more things left in the string, it just ignores those things once it's done parsing. But let's say you don't want to do that. You can do this little you should do this little left-hand operator and then type EOF, which expects the end of the file. See, unexpected G, expecting end of input, but then if we just have AB, it's able to parse that. Another important thing in Parsec is this option operator. So let's say, for example, we want to have either the string AB or string like GF or something. So it's able to parse AB, but then it's also able to parse GEF. A good practice when you're using this little option operator is to do try beforehand. And let me show you the reason that we should do that by showing what happens when you don't do it. So let's say we want AB or ADEF. So it parses AB just fine, but then ADEF, it's not able to parse. And the reason for that is the option parser, it tries to parse the first one, but then the first one consumes some characters, so then it gives up once this one fails, and it doesn't even try the second one. So what we need to do instead is we need to make it so that when the first one fails, it pretends like it didn't parse any characters at all. Oh, I need to put parentheses. So now it's able to parse ADEF, and it's able to parse AB, which is what we want. Another useful parser is the many parser. So let me just show you what it does. Many character A. So this repeats a parser over and over again as long as it's able to. And then it returns all the parsed things as a list. So we have a bunch of A's, and then if we put a B afterwards, we would be able to do this kind of thing. And it works just as expected. Another useful thing is, let's say you have no character A's. It still accepts the result, even though that might not be what you want. And let me show you what it does. It just returns an empty list. So what you might want instead is you might want to require at least one of them. So what you do for that is the many one function. Unexpected B expecting A, but then if you do AAAB, it accepts it. So all of the functions we've gone over so far, we're going to be using in parsing our statements. Just a few more operators that we should probably go over. One of them is the $sign operator, which is usually called fmap. So let me give an example with integers. If we have the integer 123, we're able to parse as an int, which is good. But now let's say we want to parse an integer and then double the result. So we want to do like times 2. And then what we would do is this little $sign operator. And that's that fmaps multiplying by 2 onto this parser. So as you could see, it parsed 123 and it doubled it to get 246. One final operator that we should go over is a little star operator. So let me give another example of why you might want to have this. Let's say you want to parse 2 integers and then you want to multiply them together. What you might think to do is this kind of thing. Parse an integer, and then fmap multiplication onto it, and then parse a space followed by an int, and then fmap that onto it again, except Haskell doesn't like that. So instead what you should be doing is for the second one and on, you use this little star operator. So now you parse the first one, you parse the second one, and then you apply multiplication onto them one by one. So that's all the operators in Parsec that we need to be using. One more that I should go over. I used space without really explaining it. So space parses white space. It can parse normal spaces, it can parse tabs, it can parse new lines. It expects exactly one of them. Another thing is spaces, which parses as many as it can. So let's say we want to have spaces followed by character A. It accepts the character A, puts some tab in. Something about spaces is also it accepts 0 spaces. So if you want to accept at least one space, you can do space and then spaces. So it doesn't like that, but it does like that. Or if you want, this is probably how it's defined internally, you could do many one space, and then it does exactly what we would hope for. So let's start to write the parsers for our statements. The first one we're going to write is a parser that accepts print. So let's just type in the string we want to be able to parse, print ABC. Just to get the edge case out of the way, we could put a bunch of spaces in between the print and the ABC. So what do we want to parse? First, we want to parse string print. Then we want to parse at least one space. So actually, I'm going to do many one space. I think it looks better. Then finally, we want to parse a variable. So the way we can parse a variable, variables are, we're just going to assume that they're all going to be alphanumeric letters. So a function for this is letter. And if we apply the many1 operator onto it, or function onto it, then we can parse at least one letter to get our variable names. So running that on our print statement, it does exactly what we want. Just testing a few more edge cases. If we put 0 white spaces, it doesn't like that. Or if we put no variable name, it also doesn't like that, which is good. And then finally, we get a string out of this, so we want to turn it into a statement. So what we can do is we can fmap this print function onto there. Let me just show you. Type print. Print takes a var and returns a statement, which is how enum constructors work in Haskell. So print ABC. If we fmap print onto it, we get print ABC, which is of type statement. So let's just throw this into our code. Print parser is of type parser statement. Note that the thing that you're parsing, the type that you're parsing goes after the word parser. So print parser equals, we can kind of just copy paste this from our REPL. Good. And if we reload, we can see that if we parse using print parser, we get exactly what we want. So now let's parse assignment. So let's do an example of an assignment that we want to be able to parse. So ABC equals 10. So what goes into an assignment? First, a variable. So we can do that using many1 letter, followed by at least one white space, followed by an equal sign, followed by another set of at least one white space, followed by a number that you're assigning it to. So this is good. It is able to parse it, and then it just returns the number that you want to parse. But how do we turn this into a statement? What we need to do to turn it into a statement is we use the fmap operator, and then later on we use that apply operator that we were talking about before. So let's just do that. We get this one parser that returns an int at the end. Put the apply operator here. And beforehand, we could put assign fmap. Okay, so how does this work? Here's the assign function. Here's a parser that parses a variable. And then, so that gets applied onto assign. And then also applied onto assign is spaces equals space, spaces, and in the end, it returns the integer that it parses. So running this, we get assign ABC 10. Note that the reason we're able to do this is because assign takes two inputs, variable and int. So plugging this into our code. Assign parser is also a parser that returns a statement. And we can just copy paste this from the REPL. Now, I'm not even going to go over how to do the add parser because it's very, very similar to the assignment parser. So add, then the first variable, and then instead of doing equals, we have a string plus equals, followed by spaces, followed by, why is that int on the new line? followed by, instead of an int now, we're going to be doing another variable, so many one letter. So let's try this out. Parse, assign parser, ABC equals 5. Good. Now let's do an add parser. ABC plus equals this random variable. Also good. So now let's say we wanted to have a parser that parses any statement rather than one particular statement. What we can do for that is that combination operator I was talking about before. So we want to use try as well. So try print parser, or try assign parser, or try add parser. So that's good. It's able to parse our addition statement. Let's do ABC equals 5. It's able to do that. And let's do print ABC. It's also able to parse that. So that's good. Let's put that before the rest. Statement parser, parser statement. Statement parser equals, gonna copy paste once again. One thing is we don't need to put try on the last one, because if that one fails, then we're done. So type check, so we know we're good. And the final thing we want to add is a parser for while loops. So let's just try that out in the REPL. Parse while, what do we want to do? While ABC is positive, print ABC plus equals B, and then put a little closing bracket at the end. Note that I'm putting a bunch of different white spaces in the middle just to make sure we catch our edge cases. So how do we write a parser for this? First, we expect the string while. Then we expect spaces, so many one space. Then we expect a variable name, so many one letter. Then we expect the string, oh wait, no, then we expect spaces. Then we expect the string positive, so string positive. Then we expect some more white spaces. Then we expect this little curly brace over here. Then we expect some more white spaces. And then we expect some statements. We want to use the many function because you could also have a while loop that just has nothing within it. So we can do many statement parser. We don't want to do just statement parser though, because these statements are separated by white space. So we want to do statement parser followed by many one space. And we're going to use this little left-hand combination operator so that it returns the statement rather than the white space. So finally, once it's done parsing all of the statements, what we have at the end is the closing curly brace. And that's good. It successfully parsed the while loop, and the one problem is that it returns a curly brace instead of a statement. So once again, we can use fmap. So while fmapped onto string while followed by many one space followed by, and then here's the var that we need, and then we use the apply thing, and then we kind of just get the rest of it, except at the very end we want to make this face to the left because we want to return those statements that we parsed. So good, this is what we want. While ABC is positive, print ABC, and then ABC gets added by B. So we could just copy paste this very long parser back into our code. While parser equals this thing. And we can add this onto our statement parser. So this is good. We have our parsers written. Now let's try it on our input file. Let's just put it to do here because we still need to do that. Actually, let's prototype this in the REPL first. So the way to read a file in Haskell is the function read file, and then you provide the file name, input.txt. And read file is an IO function that returns a string. And here's our string that it returned. If you want to have IO functions read into variables in Haskell, you have to do this little operator here. What do we want to call the file text? File text. So this reads the file and puts it into the variable file text. And if we look at file text, we'll see that that's exactly what we want. So now let's try to run our parser on the file text. So parse statement parser. Now we can put our file name in and file text, except, oh, yeah, okay, it just parses the first statement. What we want instead is for it to parse the entire file. So how we're going to do that is first, optionally, we can have some spaces before the file starts. Then we can have many statement parsers followed by at least a little bit of white space, so many one space. And then finally, followed by the end of the file. So assign a equals 5, assign b equals -1, while a is positive, print a, add ab. Good. So let's write a main function that's able to do this. Main equals do. In Haskell, this is just the way you specify IO functions for the most part. This is because of monads, which kind of beyond the scope of this video. But all you have to do, file text goes from read file input.txt. We could just copy paste that. And then we can do let parsed equal this whole thing. You know what? We might want to make a code parser that parses the entire file. Code parser equals that. So that way we can reuse it later if we really wanted to. So code parser. So we read from the file, we parse using the code parser, and finally, for now, we could just print out the result. So we're going to stop using the REPL now, and we're going to just compile this file. So ghc compiler.hs. That's going to make a whole bunch of spam here, but what we really want is this compiler file. And look at that. We see that it successfully parsed it, and here's the whole tree. So that's pretty much the end of this video. In the next video, I'm going to be talking about how to write the code generator, which takes this abstract code and it turns it into this actual output.c file that we're able to run.